So it's much more common when we complete the square to have an expression where the number of x squareds is not equal to 1. There's a coefficient here that's larger. So let's figure out how to deal with those. One big strategy in math is take a problem you don't know how to solve and first turn it into one that you've seen before. So we know how to complete the square when the coefficient here is 1. So let's do that. Let's turn the coefficient into 1. I can't just divide by -2 because that would change everything. I don't have an equals sign here. But what I can do is I can factor 2 out of everything. I'm going to leave the 1 on the outside here because the 1 isn't going to be involved in completing the square for these two terms. So I'm only going to factor the 2 out of these two terms. So I'll have x squared here, and then 6 divided by 2 is 3x. All right, so I haven't completed the square yet. Here's my advice. My advice is write down everything around the expression that you're trying to complete the square for. So this is what I'm trying to complete the square for. So I'm going to complete the square right here inside this box, but realize that everything that was here that I'm going to rewrite, all that stuff is still being multiplied by 2 on the outside, and I still have this plus 1 on the outside as well. Okay, let's complete the square. This is going to be the same as it was before. So I'm going to rewrite it as x plus something squared minus something. So half of 3 is literally 3 divided by 2, 3 halves. I know that when I expand this out, I'm going to get this term squared as extra. So I'm going to subtract that term squared. So I'm going to subtract 9/4 because that's 3 squared over 2 squared. Okay, last step. We're going to multiply that 2 back into the two separate terms. So I end by saying x plus 2 times x plus 3 halves squared. And then when I multiply the 2 in here, I'll have like an extra 2 in the numerator that will simplify with the denominator. So this ends up as being 9 halves because if I had 2 times 9/4, and a 2 up here cancels one of the 2's that's in the 4. And then don't forget, you still got the plus 1 over here. Okay, so this would be a perfectly great answer for completing the square on that problem. Okay, a couple of quick notes. Sometimes students want to complete the square like this. Let's say that this was our problem. They think, okay, how are we going to have two things that multiply to make 2x squared? And they think, we could have root 2x for both terms. And then you could have plus something. And these two things need to add up to be a single x. And you can work out that it would all make sense if that extra term was 1 over 2 root 2. I've written it out here, and you can just see why that makes sense. So these two multiplied together give us 2x squared as we want. When I multiply these together, the root 2 divided by root 2 divide each other out. So that gives me 1/2 x. Then when I multiply those two together, it's the same story. So I get another 1/2 x. And then when I multiply these two together, I get 1 over 2 times 2 is 4, times another 2 is 8, 1/8. So that gives me 2x squared plus x plus 1/8. Because the 1/8 is extra, we would subtract 1/8 here, and then the plus 1 is still on the outside. So this would be their answer for completing the square. And it's not wrong per se. It's got the form of a single thing squared. But in actual practice, this form is going to be less useful than the form where you factor the 2 out first and the coefficient is out here. So I'm going to say for the purposes of our class, even though this is helpful sometimes, let's not do it this way. Let's factor out that leading coefficient first to get the other form. Finally, 2 cautions. Be careful. You have to think about what you're doing rather than just chug along like a robot. So what if I had just given you the terms without the x squared first? I just swapped the order here. If you were chugging along like a robot, you might think, oh great, the leading coefficient is 1, so I'm going to write x plus, let's see, half of 3 is 3 halves squared, and then minus 9/4 plus 5. The problem is, if I multiply this back out, I end up getting x squared plus 3x. And that's not what I started with. So that's my first caution, is be careful about which terms are which. So let's reorder it so that the x squared is in front, because that's how we're more accustomed to look at it. Okay, so now I have a second caution. Let's factor out the 3 for a minute. So now we'll have x squared plus 1/3 x, and the 5's on the outside. So I'm going to complete the square just on the inside here. Sometimes it would be easy if you were going quickly to do this. You might say x something squared minus something, and you're like, okay, half of this is going to be 1 over 6x, and you put the x in there, and you square it, and then you think, okay, when I expand this out, I'm going to have this extra term, so I'm going to subtract 1 over 36x squares. Be careful. One of the whole purposes of completing the square is to contain all of the x variables inside the squared expression. So if you're trying to complete the square and you notice that you've got x's on the outside here, that's a sign that something has gone wrong. And what went wrong was this step from here to here. When I think about that process of writing as something squared, remember, this is going to get multiplied by itself. And so one of the terms should be x, but the other term should just be the constant. So that's the other thing that I wanted to point out. Oh, let's fix it the rest of the way. Okay, is that going to work? So yes, that makes sense. And then that's, yep. And so then I would distribute. Let's just do it the rest of the way. So 1/6 squared, and then when I multiply that back in, I'll have 3 in the numerator. Well, I guess let's write it out. 36 plus 5. So 36 divided by 3 is just 12. So that's the same thing as 1/12 plus 5. All right, I think that's it. Come back in the next video for the A level of this.